This lesson explains the very special string class of Java. It's not one of the fundamental data types, but it is a very special type. The string class is actually a part of the Java language because the compiler knows how to use it to generate special code for it. This is the main window of an application. It has the same form that we've been using in some of the previous lessons. It extends a frame class and then creates a string demo object and adds it to the window for display. This is the string demo class, which extends the canvas object. It demonstrates some of the different ways of creating string objects. As you'll soon see, anything in Java can be automatically converted into a string object. At the very top of the paint method, we call getBounds to get a rectangle object containing the bounds of the window being displayed. We also call the getFontMetrics object to get the size information of the current font. We're going to display several different strings in the window, so X and Y are initialized to the position of the first string to be displayed. Now here we have the declaration of a reference to a string object. Remember, because we have not stored anything into the references yet, its value is still null and no string object as yet exists. Now this line of code creates a string object containing the quoted characters and stores the address of the object in the reference. This statement is, in fact, identical to the function statement that follows it, where the string is explicitly named and a new statement is used to create the object. The compiler does this. Whenever the compiler sees a quoted string of characters anywhere in your program, it inserts a new string statement to create the object. And this statement is exactly the same as the ones above it. It's just written in a different way. You never have to write new string because the compiler will always do it for you when it finds a quoted string of characters in your code. This call to draw a string draws the first string in the first position of the window. The window produced by the program looks like this. This top line is the one that's displayed by the first call to draw a string. Notice the use of the addition operator in this next line. It's used here to create a new string object by combining the contents of string 1 with string 2. Whenever the compiler finds a plus sign with an item to its left or right being a string object, it knows that it's combining two strings and it creates a new string object to hold them. This call to draw a string produces this line of text, which is a combination of the first of the two strings. Now notice how the position of the second line of text is determined. If you recall, the height of a font not only includes the height of the visible text, but it also includes the height of the leading, the space between the lines. So it's only necessary to add the height to the current position to determine the position of the next line. The next string is constructed by using the plus equals operator to add the next string to the one we already have. Now you should be aware that although this statement looks like it's combining a new string with the one that already exists, that's not actually the case. The string objects are immutable. That means that once they're created, they can't be modified. This statement actually is creating a new string object that replaces the existing one. The operational difference is moot in this particular case, but other circumstances will arise where the difference is important. Anyway, the resulting string is displayed here, and it contains all three of our original strings. Here we declare ourselves an integer value that we want to display. The integer value is converted to a string here by simply being added to another string object. Here's the deal. Whenever you add two things together and one of the things being added is a string, the other one is automatically converted to a string, and the two strings are then combined to form a new string. The output looks like this. You can add several strings together at once, and the conversion thing still holds true. Here are several plus signs between values and strings. one of the value being an integer, the other one being a float. The result is a string with both an integer and a float. You can add as many values and objects as you wish to a string, and it will always produce a new string with everything you've added to it converted to a string if necessary. Now, in these statements, 3 separate objects have been converted to strings by being added to existing strings. As you can see, each object, a color, a rectangle, and a font metrics object, have all been converted. Each one displays in its own way. A color uses its 3 internal values, a rectangle uses its 4 internal values, and a font metrics object displays all of the font metrics information. You'll find that other objects produce simple strings that include only their names or even just a text version of the address of the object, but the point is that everything in Java can be converted directly to a string.